G-Stash, episode 3, intense and lots of ice, here with Alex Watts and Kevin, and of course Jasper, CTO from SEDA. Kevin is one of the founders from the Khalani network, and Alex from FastLane Labs. This is going to be an epic conversation. Thank you so much, everyone, for joining us today. Look, there's a lot of pre-podcast banter going on. There's a lot to dive into today. We could start kind of anywhere, but I think we've got 3 very cool projects here today with SEDA, Khalani, and FastLane, all kind of solving different things that are very collaborative in nature. So maybe just as a really quick kind of intro, Alex, we'll throw to you first. Just a little bit of an intro on yourself and what you're doing at FastLane Labs.
So my name's Alex Watts, aka Thogard, and I'm the co-founder CEO over at FastLane Labs. We make smart contracts that can be used for sequencing. But what we found is that when you start using smart contracts for sequencing, you gain a certain level of programmability that has a wide range of use cases. We do this for validators, we do this for apps, we do this for intents. And in general, we're fascinated with the programmability of sequencing with smart contracts.
Amazing, which is actually super in line today because we're going to be diving into A.S, which is really, and you guys are doing a lot of, before we move on, you're doing a lot around MEV as well, which I want to touch on, especially in kind of like a solver cross-chain intent world and sort of understand where MEV sits into the picture, but we'll dive into that later. Thanks, Alex. Kevin from Khalani Network, I'd love a little introduction on yourself and what Khalani's doing.
Hey guys, so I'm Kevin from Khalani. So Khalani Network is a platform to build, to facilitate, we call collaborative solving, to build solvers. And I think solvers typically are understood in the context of intent-centric interactions. But I think I'll just mimic what Alex said. So sort of during the last this year, also building up this platform, we actually discover a lot of the off-chain infrastructure or off-chain, applications, you may say, are also kind of fundamentally solvers, right? And we can, we can dive that into that in this conversation. I think
I was just about to say that's one.
That counts.
For all the punters, we're going to be keeping track of Kevin definitions. If you're not sure why, jump onto his Twitter.
I do not define intents. I do not.
No, but you define the infrastructure as solvers, and that counts.
Yes.
It counts.
Yes.
Yeah.
Cool.
Solvers.
I have 2 opening statements that I want to start this podcast with, or whatever stream. The first one is this industry is clearly underexposed to A.S, which means 2 things, and both are true. And the second one is solvers are the next CK. And what I mean by this, I love to frown. I wanted some frowns. Yeah. Like, what the fuck does that mean?
I'm not frowning. I'm just curious. That's like
exactly
stuff.
No, it's the scapegoat for lack of progress or lack of shipping that we're gonna see in the future. It's gonna be like, or it's like, you have so many people that are building like super complex systems, but when asked about like how does this actually work, they say, oh, it's solvers. And they just like people say like, oh, but how do you secure this? And people say, oh, we will use CK, right? It's like this sort of like umbrella term that people use to sort of like save their ass in when they're in technical trouble. Thoughts?
Dude, at first I thought you were going to say something along the lines of like solvers are going to be computing like ZK proofs in a race to see who can like settle cross-chain first. And I was like, that actually makes a lot of sense. We've actually talked to a handful, like more than one team that was working on a PEV network, proof extractable value, which is interesting. Very interesting. Maybe not in the immediate future though. Will it be live? But no, I think, at the end of the day, like solvers, let's just have a solver take care of it. It's something that a lot of apps and a lot of teams have been saying. And like the funny thing is that like honestly, if you assume an infinite amount of solvers, then honestly, solvers can do a lot. And what I find to be really like the main friction point there is that there really aren't an infinite amount of solvers. My background, so before I started FastLane, which, I call us a smart contract based sequencing company. Other people might say that we're an MEV company, which I think is probably also accurate. And so before I started FastLane, I actually worked as an MEV searcher, searcher being another one of the many, many names for solver. And I did market making, I did atomic arbitrage, I did liquidations, like all of the above. And oh my gosh, it was a full-time job. And it was very, very difficult to, like, very time consuming to start searching or solving on new apps. And I would only do it for ones that had like a lot of volume already. And so to me, when I hear like brand new teams or chains or apps talk about how, we're just gonna have a solver take care of it, it's like, yeah, you can, but you got to make them care first, right? Like you have to offer them something. They're not just gonna they're not some public good that's just gonna like flutter down. They're very revenue driven, and it takes a lot of infrastructure. It takes a lot of programming. It takes a lot of security assessments and audits before they're comfortable solving. And so, yeah, it's one of those things where, like, yeah, I mean, if you're Uniswap, you can get a bunch of solvers to do Uniswap X. If you're 1inch, you can get people on 1inch Fusion. Like FastLane has, I want to say like 60 or 70 different searchers at any given point in time that are going through our network. It took us 6 months to build up to that, though. For the first 3 months, whenever there was MEV, like the bid to value ratio in terms of like how much value there was and how much the searchers were actually bidding was like sub 75%. Like a lot of times, the first 3 months, it was like between 50 to 75% bid to value. And so, yeah, it's like, I do think a lot of people are taking solvers for granted. And there's definitely a cold start problem inherent into that ecosystem.
Yeah. And then, Kevin, what are your thoughts about that? How are we going to fix that?
Yeah.
Because they're such an important part of these new products coming out. And yeah.
I very much agree, right? I think this is very analogous to maybe DeFi before AMMs, where, like AMM is not the first on-chain DEX. There were attempts that clubs or club-like decentralized exchange on-chain, and that will very much depend on market makers. And it was just difficult because anybody can launch a market, for example, a club. But it's the market making that's difficult. If you don't have enough market makers, then who's going to come here to trade? And then for market makers, why am I going to integrate your, the 10th, 20th different on-chain club, right? And I forgot which year Uniswap started, but after AMMs, I think things start to change very rapidly because it's just a lot easier to get people started market making. It's not perfect. It's not the most efficient, but you can get capital on chain and then sort of start making markets, right? And then that's where on the taking side, people come to trade because they know liquidity is there, and so on and so forth, right? So I see right now we're at this sort of pre-AMM era, whereas people talk about like solvers and market makers, right? So onboarding solvers is still very, very challenging, and solvers are also very selective. They can't just afford to start integrating every single intent applications, right? And I think what we're trying to do is try to emulate this AMM moment and just make solving or like call them market makers. That's fine. Super easy. Yeah, and hopefully after that, it will be a lot easier to onboard these guys.
That second definition, Kevin, I want to ask you on that.
I don't, because the MM in AMM stands for market makers. So I think
exactly.
we'll let that one slide.
All right.
Cool. Automated market makers.
I'm trying to hit my 14 definitions, my guess. One of the things that I'm noticing all the time on crypto Twitter right now, right, is like we're all parroting this kind of like chain abstraction end state, and we're creating this expectation this kind of industry expectation and a lot of people that are looking into the industry who want this, glorious app experience that's just going to feel incredibly like unified and just like being on the app store and you're just clicking to apps and do whatever experiences without interacting with the chain. But it's becoming very, very clear that, and especially with what you guys are saying, that the solver section of the stack is just so far away from providing that experience to meet that expectation. Can you just sort of zoom in a little bit, Alex and Kevin, on what's it take for a solver? Like, I think it's becoming very clear what's going on in the settlement, like around, kind of what we're doing with oracles. People sort of seem to understand that. Universal accounts are, becoming very clear about how they're working. But as you said, Jasper, it's like, yeah, there's just solvers in the middle and everyone kind of zooms out of that part and just goes to the top or the bottom of the stack. So, what's it take to run a solver and why is it so difficult?
Takes a lot of pager duties going off at 3 a.m. I can tell you that much. My favorite horror story was my wife and I were actually, so I live in Los Angeles, and my wife and I are going on this vacation down to San Diego, which is like a 2-hour drive away. And I promised her, I'm like, babe, I'm not going to let this weekend get ruined by MEV, because like when you do MEV, when you do like searching, it's a full time, not that. So I'm like, babe, listen, like if anything happens, I'm just going to remote, like shut off all my nodes and we're going to be golden. And of course, we get down to San Diego and I look at the like Block Explorer and I'm like, my bot just randomly decided to burn $500. It just lit $500 on fire for no reason. It's probably a one-time thing. And then 45 minutes later, it lit another $500 on fire. And then 45 minutes later, it lit another $500 on fire. And I'm like, I don't like the pattern. There's still a lot of other like 45-minute increments left in this weekend. And so I busted out my laptop and I shut down all of the servers, all of the nodes I was running. I think I had like 15 or 16 different nodes at that time. And then I remember that there's one node that I can't remote shut down, which is the one in my house, which I am no longer privy to because I am on vacation. And so I'm like, fuck, like, babe, I'm so sorry. I think we might have to drive back to LA. Like I'm sorry, but it's literally lighting money on fire. I can do a quick little graph here and extrapolate how much money we're going to lose if we don't drive back. And she was so mad and I felt horrible. But then I remembered I had my neighbor's like phone number. So I called up my neighbor and I'm like, dude, can you do me a favor and turn off the circuit breakers for my house just to shut off that one last node at my house? And thank God he was there. And so he literally just like went around to the back and he flipped the circuit breaker, shut off the computer in my room. And when we got back from the vacation, a lot of the stuff that was in our fridge had gone rotten, but at the very least, our vacation wasn't ruined. And that was a success. And that is very much what it's like to be a searcher.
That is the side of solving no one talks about.
Yeah, exactly. I think what this really boils down to is like it's not a one-person job. You need companies running solvers. And that is something that there's just not that many right now. And the question always becomes like, will there be many? Or is this like a winner takes all, race to the bottom type scenario? Or is it like blue chip solvers will be like 2 to 3, and the long tail solvers where maybe sort of like the larger solvers don't want to spend time on the crumbs. After there's like hundreds fighting over the crumbs on these long tail sort of like chains or protocols. What's cool here, and I think after we answer this, I really want to dive into taking a step back and like talk about application specific sequencing and what the hell it is, because we dove right into A.S., and I know that sometimes people get like that, but I think we should take a step back and sort of like go over the definition. But before that, what do you think, Kevin, like working in this super solver heavy space, like how do you portray the future?
Yeah, I think it's the number of solvers really depending on the number of different markets, right? So if there is only, for example, CalSwap and on Ethereum, and nothing left, there won't be many solvers. Maybe that market will sustain, I don't know, 10, 20 solvers total. But as you have more sort of applications or intent sources or wallets and so on, and you have multiple chains, right? So the more fragmented the demand side is, then the more sort of opportunity it creates, so that it will not just be like 5 solvers total or 10 solvers total, because the integration effort to integrate everything is just so significant, and then the long tail just become no longer, increasingly no longer worth it. Then on the solving side, you also tend to have more sort of supply to meet the demand. On the other hand, it's difficult to imagine a world where there can be that many sort of intent applications or chains if there are not enough solvers, right? So this is actually what we, when we talk to solvers and people tell us is actually on both sides, right? You talk to intent application developers and they say, we talk to solvers, but they have a very, very long integration pipeline, and who knows when they're going to start integrating us. And then we talk to solvers, to the same thing. It's like we just can't afford to integrate every single one, because every single integration is sort of pairwise, right? So they may have spent 3 months integrating with FastLane, and then like, okay, what's next? Or we'll have to monitor FastLane. I can't integrate 10 more FastLanes this year. That sounds crazy. So yeah, and that's what we'll be hearing. I think explain to some extent the current status quo, that sort of both sides are trying to look for the other, and but I think if we could make the cost of both creating solvers and integrating with solvers much lower, then we'll definitely see the demand side coming up, because the UX problem is very, very real, and people realize that sort of tapping into intent and solving can solve all the UX issues.
Alex, how would A.S result in acceleration of more sort of like solving opportunities and sort of like more long tail solving opportunities? Does it at all? Or is it not affecting that?
It's a really good question, and I actually don't think it does. I think if anything, it slightly reduces them, but I also don't think that that's a bad thing. So when you're looking at like running a searcher bot or a solver bot, and just to be like slightly, or just kind of like cut straight to one thing that I think is critically important. When you're doing like MEV and someone does a swap and you do like an arbitrage trade, let's say someone does a buy and then you do a sell in the pool they bought in, and then you do another buy in another pool. You're just doing 2 trades as a searcher. You're selling in the bad pool and you're buying in the good pool. If you're just fulfilling a swap intent for a user, then you're just buying in the good pool. But the math is exactly the same. If anything, the math is a little bit easier if you're fulfilling a swap intent than if you are doing like a backrun arbitrage type of MEV. And the reason why I bring this up is because, like, when you're looking at application-specific sequencing, and this is true for both intents as well as for just internalization of MEV, like you can use A.S.S for both of them. But what's interesting is that like you start to like slowly not lose, but like reduce the ability of these apps to compose with each other. And what it means is that you start to have like apps where it's like, this app is going to say, this is my MEV. Another app is going to say, hey, this is my MEV. A third app is going to say, hey, this is my MEV. And so you start to get more of like I don't want to call it like a localized, because like these apps can still compose with each other. It's just that they're not sharing the MEV. Before you had A.S.S, all of the MEV was going to the validators. And the validators don't really care like what the order is of the interactions with the apps. Like the validators are just like, all right, we'll just sequence these transactions. We're validators, just give us the money. But like now it is slightly reducing just like the number of edges in the graph that we are traversing when we are looking for these arbitrage opportunities, just because you do have like a more of like a focal point that each app represents, which means you can't necessarily combine 2 different MEV opportunities into one as easily, which does reduce the number of like searchers a little bit. Slightly.
Well, you can, but it requires coordination and cooperation.
Yes.
And not only that, it also requires negotiation, because how the hell are you going to quantify which app has right to how much of the MEV for certain transactions, right? Like that's super difficult.
It's political.
Can we? Yeah, it becomes it becomes fully politicized. Very interesting. Can we take a step back before we dive more into this and talk about what is application-specific sequencing if you compare it to sequencing as we know it today?
So a very good question. I think that there are a lot of different definitions of application-specific sequencing. So I'm going to give mine. And this will be like a definition for Alex. But for me, application-specific sequencing is when an application takes different actions. And these actions could be transactions. They could be EIP 712 messages. They could be like meta transactions. They could be intents. They could be anything. But the general idea with application-specific sequencing is that the application is enforcing some sort of ordering or sequence of these actions. And there are two real constraints here that like really make it application-specific sequencing. The first is that there is no dependency on the validator to do this. If you get the validator to do it for you, either by like bribing them or by like bonding them and threatening to slash them, then that's not really application-specific sequencing. That's just validator sequencing with extra steps. And the second thing is that you want to have the ability when you're sequencing these actions, let's call them, to include the actions of adversarial actors. And it's critically important when you are putting these, the sequence of events together, that you build around the fact that some of these people really don't like each other. Some of them are counterparties from each other. Some of them are competing with each other to, let's say, if you've got a swap intent, some of them could be competing to fulfill the swap intent. And so the general idea is that like with ASS, you want to do it in a way that doesn't depend on the validator, but also in a way that can work even when the parties being sequenced just really don't get along.
I think I like that definition. If I could take a step back and sort of like compare this with like what we were seeing today, like today you have a smart contract, and if somebody wants to interact with that smart contract, they send their transaction through an RPC, it ends up at a validator, the validator includes it, right? In a certain order. And if it passes the conditions of the smart contract, the transaction will pass. Those conditions historically have been business logic on whether it's a valid transaction based on the merit of the protocol, like what the goal of what the protocol wants to do. Application-specific sequencing sort of adds a new condition that to the smart contract, for the most part, that says, hey, this transaction has earned the right to be included at this height, or at this in this sequence, right? Is that sort of like a practical example of how this would work? Like there's just like this new set of conditioning that not only takes, go ahead.
I think that's one type of application-specific sequencing, but I don't think it's the only type. But I do think that is one type, absolutely.
And so it removes some of the power of the validator, right? Because the validator right now has the monopoly on inclusion. And the smart contracts or the applications basically say, hey, we want to have a say in this too. And that removes sort of like this monopoly on inclusion, which is very valuable, right? It's like the monopoly on block space almost.
Well, I mean, not to get like too technical, but the proposer monopoly is a tricky thing to get around in a lot of different scenarios. And I don't think that we're ever on Ethereum or any other single leader consensus spec going to get around this proposer monopoly anytime soon. But what we can do is we can make it so that there's not a strong profit incentive for the proposer to censor. And so the way that FastLane approaches this with Atlas, which is our application-specific sequencer, it stands for anti-transaction level application sequencing. Anti in this case being before, like ANTE rather than ANTI. But the general idea is that with Atlas, we're taking these meta transactions, these little mini transactions, and we are sequencing them together before it even becomes a transaction. But we take these operations, these mini transactions, meta transactions, whatever you want to call them, and we just jam a bunch of them into a single fat transaction. And the neat thing about doing this is that, well, one, because it's a single transaction, all these meta transactions inside of it can actually pass call data back and forth to each other. They can like call in, they can have conditional reverts, they can like reference each other in a very programmable way, which gives a lot of control over stuff, which is neat. But from the validator perspective, the validator can't really come in and like selectively censor some of them, but not others. And so with Atlas, the general idea is that like we've got just one fat transaction, the whole thing is all or nothing. And so if the validator wants to censor it, they still have that proposer monopoly, right? They still have that proposer monopoly. We can't get around that. But what we do have is like there's not really a reason for them to, because there's not a there's not like an incentive. Because if they censor the part of the transaction that is capturing any sort of MEV or fulfilling any sort of intent in a way that generates profit for the searchers or solvers, they're also censoring the thing that creates that opportunity to begin with. And so then they just have a block with one less transaction, and they're going to lose in the PBS auction. But yeah, so it's like that's how we approach it. There's other ways to do it too, but yeah, the general idea is trying to find like ways to tinker with the incentives.
So would it be fair to end my sort of like take on this with it removes the monopoly on ordering, but for a certain bundle of transactions for towards a smart contract, but it doesn't remove the censorship monopoly.
That is correct.
Kevin, do you agree with Alex's definition?
Yeah, I mean, in the context of Atlas, definitely. Right, but application-specific sequencing you can also explain from other perspectives. Like one way that I've been talking about this lately is it's a form of local consensus, and for most current blockchain like smart contract chains, there is just single global consensus, which means when you sign a transaction, you just throw it into the public mempool, and then somehow these validators agree on some sequencing rules, and then the transactions get packed into blocks and so on and so forth, right? Now, is there a way to opt out of this global consensus because people are starting to realize this power of sequencing transactions is actually very valuable, right? And they may not want to give this up all to the validators. And this is where solutions like application-specific sequencing comes out, allows the apps or front end to send transactions to not to the public mempool, but to some private mempool, where they can be sequenced before they hit the public mempool, right? And then the way that it's sequenced can extract value or can or prevent extraction of value, depending on how you look at it. And then that value can be returned or directed to this off-chain component. So that's another way to think about app-specific sequencing. I think that's the motivation behind a lot of the solutions. Yeah.
Lovely. I almost hear application-specific sequencing turns smart contracts into rollups.
Smart. What? Say that again?
It's almost you almost turn a smart contract on an L1 or L2 into like Ln+1.
It's a spectrum.
Yeah.
I think that application-specific sequencing and rollups have, like if you're looking at the spectrum, they are right next to each other. In between the two would be based rollups, where you have sequencing on one side and execution on the other. But yeah, absolutely, it's a spectrum. There are a lot of similarities between the two. It's really just a matter of what you do on chain and what you do off. And you can just you can take apart pieces of it and move it off chain. And the more you move off chain, the more control you have. And it's like a ship of Theseus type thing. But I don't disagree with what you're saying, Jasper.
It's like rolled up transactions that onto a smart contract essentially that settle every time it's deemed relevant. Interesting, love it. So we jump into the role of solvers within this system.
Can I?
If you start with the app-specific sequencing, and if you also if you just keep the assets on chain, you remove the on-chain pricing algorithm off chain as well. Then that becomes application-specific solving, right? It's still application-specific sequencing, but
can you do that again? Do that again? Can you just say that one again, Kevin?
Okay.
So if you do nothing on chain but settlement of assets.
Okay, so let's say you have Uniswap v2, right? You have an XYK curve.
Yeah,
right?
yeah.
So of course, you can do application-specific sequencing. You can keep the XY curve on chain, and they say, hey, I'm just gonna auction off the right of sequencing. Who gets to touch this curve the first, right? That's sort of app sequencing. But what if you remove the curve as well? So all you have in the contract are just like X and Y. There's no K, right? There's no bounding curve in the contract. It's like almost like a bridge contract. You have two assets in the bridge contract. And then you say, well, I mean, in that case, you're not going to auction off, sequences, but you basically says, I want to trade X to Y, and then who gets to give me the best price? So you're moving the pricing curve also off chain. So sequencing becomes solving in that case, right? So whoever gives you the best price got to withdraw your X or withdraw your Y, in other words.
Interesting.
So that's where sequencing becomes the solving.
I think that this sequencing informs on who gets to solve, but this is kind of where, it depends. So it's like take CalSwap, and God, I hate to do this. So it's like there's like solving. Like, what is solving? In CalSwap, I like to pick on CalSwap for this because CalSwap actually has two very different types of solvers. They have one type of solver where this solver's job is to come up with the best way to batch all of the orders together. And then they have another type of solver, which is where this dude's like, hey, I've got some inventory. I'm going to, fulfill the deficit and figure out what the best route is to handle this, deficit. And so in reality, this is typically the same entity doing both of these things. 9 times out of 10, it's the same entity. But there is this kind of distinction between the solver, the counterparty, and then solver, the person who matches counterparties with each other. And Kevin, I think what you're saying is that the sequencer becomes the latter, in that it is the one that sort of handles counterparty matching.
Stateless. The sequencer is the stateless one, right? It doesn't really have
you can jam state in there if you want to, if you don't mind a
little
bit of gas fees.
Other people, insert states into it. Say, hey, I'm bidding, right? I'm bidding into this auction, and then the auctioneer is the stateless one, right? So I don't have state, but you guys push state to me. I'm just gonna pick the best one. It's like a pure function. The bunch of inputs, I pick one as the output.
I mean, you can definitely have state, especially for things like reputation and order flow, toxicity, metrics and things like that.
Right.
You don't have to be stateless, but I think in most cases you are right. In most cases, it's typically a relatively naive stateless function.
So intents are limit orders.
Yes,
the conclusion.
Pretty much.
So L2s are bridges, and intents are limit orders is like the two things that I've heard out of the Solana corner over the last.
And solvers are sequencers.
Yeah. Yes.
Or maybe
all new things. Or yeah, sequencers are solvers. Yeah, to some extent, you could say so.
In FastLane's model with Atlas, we actually do have these distinct roles between like the solvers who are the counterparties, and then we actually, just because like definitions fucking suck whenever we're talking about this, we call the entity that does the matching like the auctioneer. It's like they're taking in the bids and then they're sorting the bids, and then they are like handling the matching. But we wanted to give it a separate name just to make our lives a little bit easier when we talk about it.
I think that subcategorizing solving into multiple definitions is something that we need to do anyway. And I think we've already have. It's just that people don't understand that solvers is the umbrella term for many other things, right? Like they hear solvers, they think relayers. I think even though searchers, as they were called before, are the original solvers, then when people are like, oh no, this is becoming too much of an umbrella term, let's call them solvers. And now you have like fillers and I don't know, relayers and all of these different types of mechanisms that all fall under this umbrella term.
Yeah, the cool kids call them agents nowadays.
Makes me feel old.
It's another subcategory. It's just like AI powered solvers or AI incentivized solvers, I guess.
Yeah, I mean the way. Yeah, go ahead, Alex.
You know what? We don't need another tangent story from me. we can keep going. I'll save it for some other time.
I want to, because we're closing into the end of the hour. So a lot of people are asking in our community when we started talking, or when I started talking about, solvers not being ready for kind of this expectation that we're going on, and we've got app-specific sequencing. I want to kind of get your guys' prediction on where we're heading with all of this, because there's just so much there's so much talk and movement towards this 1,000 app chain world, which is going to require, arguably however many solvers to handle however many intents per second. And now there's this new meta coming in of AI agents are going to be running the whole show. Basically, everyone's going to kind of have their AI agents. But can you guys just give us the real story? What are we actually moving into here? Because it's definitely not that in 6 months' time.
So I actually will tell the tangent I didn't say a second ago, because it's 100% relevant for this. I was sitting down with Kubi, who's the CEO of Titan Builder, the block builder, the relay, and we were just hanging out, and a researcher was there too, and he asked, he was like, guys, how infiltrated are these solver networks with AI? Are these block builders using advanced learning patterns? And Kubi and I just look at each other and we just start laughing, because searchers and solvers are just so much less sophisticated than you would believe, because there's really not a lot of value. If you're a searcher or a solver right now, there's really not a lot of value in getting a PhD in some obscure thing that can slightly optimize one thing to be 0.0001% better. There is a lot of value in just going on Twitter and seeing what all the degenerate people are trading on, and figuring out how to multiply X times Y equals K, and figuring out what new dexes are popping up that are forking that. And so or maybe there's a new chain, you have to figure out how this chain's RPCs are different than the other chains, and how the sorting algorithm is different. But it's none of these things are really mathematically dense. You don't have to have a PhD to do this. You do have to have time, and you have to have patience, and you have to be very thorough, especially because solvers do a lot of PvP. A lot of times searchers will drain each other's contracts, things like that. But if you're trying to just do hardcore optimization, you can spend a lot of time on something that makes you marginally more profitable on an already highly competitive field, where the actual value retention just from competition has been compressed down to a really small amount. Meanwhile, you could just go launch on some new L1 that's degenerate, and make a fuck ton, and not do any math more complicated than what you learned in elementary school. And so to me, it's kind of people can do all this fancy stuff. It's just, that's not where the money is. And if you try to do all that fancy stuff, like you're not going to last very long. Is that going to be how it is 5 years from now? I mean, God, I hope not. Like, I genuinely hope that we get to a point where like deep learning modules are like actually useful. But like, do I think that trading shitcoins is still going to be the most profitable thing to do as a searcher or solver or whatever 5 years from now? Honestly, probably, yeah.
I just paraphrased you on Twitter, Alex, saying that you just said you solve simply for the love of the game.
Hell yeah.
It's just out geeking the rest.
Kevin, what's your take on it? Because you guys are building like arguably, I don't know, I phrased it the other day as like the Ethereum for solvers, but it's kind of like this network or platform like for launching solvers. Is kind of what I got from some of the pods I listened to you.
So I think the the bullish case for solvers is that every user may want to have like user aligned solvers, right? So because in the multi-chain world, moving assets around, it just kind of it's both cumbersome and also dangerous in the way that it can be extracted along the way. So having user aligned or account aligned solvers is advantageous because they will prioritize and execute on your behalf and also optimize on your behalf as well. So any sort of MEV along the way, whether it's trading, whether it's going cross chains, whether you want anywhere between the speed, latency and price trade-off, things like that, your own solver can carry your own preference and just execute for you, right? So that's the bullish case for solvers. Everybody may have different preferences. Some users don't care how much they pay; they just want to get to trade that, meme coin as fast as possible. Where others may just be price sensitive and want to save the last penny, right? So that may be the bullish case for solvers. That they're going to be aligned. I mean, in a way, they're being aligned with users, and then they can also be aligned with LPs or liquidity providers, and in a way like applications, right? Because LPs also don't want to get extracted. So every liquidity pool may also want to have their own aligned solvers that basically return the extracted value back to the LP. So that's the bullish case for solvers. I think that will happen, especially like chain abstraction is a pretty sort of big trend right now, and then the user experience, and we're not even talking about like optimization, just simple user experience. It just have a lot of room to be improved.
I think like to kind of piggyback off of Kevin's point, I think that like what we found is in terms of returning value back to users or returning value back to liquidity providers or just like passive like capital. Typically speaking, you can use application-specific sequencing to do both. And like with Atlas, we actually do both. And it actually improves the UX too. And it's interesting because like with when you're returning it to liquidity providers, you're typically giving money back to passive liquidity. And so that's where you like typically are dealing with some sort of exogenous MEV where like some price signal somewhere else happened. And because this price signal somewhere else happened, you have this activity that is happening on chain and you want to sequence it. And you want to make it so that like this person who's trying to collect this value by doing this, like, taking from this stale liquidity, you want to force them to go through some sort of application-specific sequencing gate. And that gate you can then program to redirect any sort of competitive auction value, the proceeds from that, back to the liquidity providers. Meanwhile, if a user is generating the MEV, the app already has control over that. It's endogenous MEV, and so the app can sequence that just directly with a solver who's also giving it straight back to the user. But I like that first case with the liquidity providers because one of the things I'm really interested in is like how oracles and how like, especially like, I mean, obviously like SEDA, But I feel like that first case is actually a really fascinating intersection where like SEDA has this like extremely programmable Oracle network. I feel like you guys have definitely spent some time thinking about this, and I don't want to like, accidentally show you guys, but like I genuinely want to know, like, how do you guys see like SEDA fitting into, in particular, like returning value to liquidity providers? Because I feel like you guys have like, that's like really cool use case, right?
Yeah, we've thought about it before. Like one of the things that we talked about with some of our friends in the beginning that are like also very deep in the MEV space is like building this DEX that's fully Oracle based, and try to like unfuck LPs a little bit that way, but you still get into like really important latency games. And to unshow us a little bit, this is not something we are competing on right now, but it's definitely something we want to like optimize into the future, and then it will become more interesting, in my opinion. You'd have to model out if there is a little bit more latency on Oracle than the block time of a destination chain, whether there's still stuff to gain, but I'd assume the LPs would get screwed over more than in the sort of like X times Y equals K case.
Maybe.
Yeah, it's something to model though.
I think you're right though about comparing the latency of the Oracle network to the block time. I mean, at the very least, you would need to have some sort of like the Oracle updates have to be like inside of the bounds, otherwise it's just going to be late to everything.
Yeah.
But I think like if you're forcing, like, one of the things I think
there
is really cool is,
yeah, no, I just now that you're talking, so to interrupt, because I just had this kind of aha moment. There is like a new DEX design that could work in which you batch it based on price updates that it gets in, and like it always has to get executed on the right tick on the right price at that moment, essentially. Like that is an option. So you essentially gather transactions. The transactions have slippage. Let's say the Oracle time is 3 seconds, block time is 0.5 seconds. The whatever 6 blocks that have orders in it only execute on like the 6th block with like the latest price update, and if it surpasses slippage, then you don't execute it on those transactions. I
thought about like an idea like that. I actually am a Uniswap contributor. I put in like the no-op part of Uniswap v4 specifically with that exact idea in mind. But like what we discovered pretty quickly was that if you have like users send something in and then they get fulfilled in a later transaction, then it disrupts the front end because you don't really have as easy a way to keep the user updated with like exactly what's happening every step of the way.
It's also really like your intent will be used against you type scenario, I think, in which there is like a lot of MEV you can do with the sort of like promise of execution with an average slippage. So you always try to hit the average slippage or the median slippage on the end of the block as a market maker by like selling or buying or whatever, and it makes sense.
Let me pose you a question though. So like SEDA, like Oracle network, but it's programmable, right? So like technically speaking, we don't have to actually use like a Binance or like Coinbase price feed. Like what if we just like ran an auction, and then like every 3 seconds you run an auction, and like and you match this auction duration up with the block time. And then if anyone wants to swap in that pool, they have to go through this auction mechanism. And it's like maybe they don't win the auction, but they still get batched like with the auction, or like they have to have like been willing to participate in it as a way to like
prediction markets.
Yes, exactly
it's
that.
Like future key on pricing.
And so that way you don't have like the Binance race to Tokyo, but you do have this like, you still have this like gating mechanism where SEDA is still like providing like an updated price feed. I believe you guys are a pull-based Oracle, right? And so like that would be perfect for that. Like the users could just pull like a proof that they were, not a proof, but like a signature or something that they were participating in the the
Exactly.
option.
Yeah. We can do something like that for sure. That
I mean,
sounds.
I think that would be a very, like, I don't want to say simple. It sounds extremely complicated, but it's
Yeah,
definitely
yeah.
a solution
Elegant.
that would work. Yeah.
Let's say
And
elegant. Let's go
yeah,
elegant.
and it's like you could run them anywhere. There's not like you wouldn't have to do it in a centralized way. I think that would work really well. I think that would be pretty effective.
You can build like Khalani.
Yeah, hell yeah, let's do it.
The auction
I think-
itself. Yeah.
I think we need to anyway. But guys, we are at the end of the hour. I have one last question that is on top of my mind. I can go over a little bit as well, and that is, if you'd have to rate the level of involvement of solvers in today's ecosystem, where are we at today? And where will that be in, let's say, 2 years?
Ooh.
You have to increase what?
Oh,
Involvement.
the involvement of solvers. Like, let's say, I don't know, or you can do a percentage, right? Like, what percentage of sort of like involvement do the solvers have in today's ecosystem? Because there's still a ton just being routed through uni fee. We can do trading even if we want to, but like there's still a ton being routed through like Uniswap, for example, right? Where, I mean, let's discount searchers out of the solver sort of scheme. What do you guys think?
Yeah, I think inventory is the biggest barrier, right? I think especially that, given the fact there are going to be more and more meaningful chains, and then I think there's definitely going to be more and more markets. So kind of going back to the point that I made before, the more markets that there will be, then the more opportunity for solvers to be built and then capture these markets. I mean, from our point of view, I mean, this is definitely the problem we're trying to address, is we want to lower the cost of building solvers. You could kind of think about Khalani as like a very counterparty-based approach, that if you want to build a solver, we allow you to enter into agreement with different counterparties, right? So whether it's about settling into base, whether it's about trading with Uniswap, or just doing cross-chain, you can rely on other solvers to be your counterparties, and then so you can just build a pretty simple algorithm, and then rely on like 3 or 4 counterparties to integrate with most of the intent apps, right? So that is kind of the mental model that we have, and we want to provide infrastructure for. I think it will move the needle meaningfully for building up solvers. And this is like very, like, think about TriFi, the way you build, like if you're a quant or financial engineer and whatnot, you're not really thinking too much about how to settle into a specific exchange, or how to move money from a bank to a brokerage. You're just not thinking about that, right? So somebody else is doing that for you. And you can focus on, for example, just writing code for a very efficient strategy, right? Which is just math, right? So think about how to do. I mean, execution. Their trading desk can do that for you. So that's what kind of the future that we think that will happen. And if we could build that, then I would say probably 100x number of solvers, and just lower the barrier for that to entry. Then we can see a lot of things will meaningfully change, on the UX side, on the demand side, and so on. So yeah, so that's what we see.
I think from FastLane standpoint, I mean, I think all 3 of you guys have seen our smart contracts and just our general approach. We're looking at it from a, like, let's not have to deal with the cold start problem situation, because we do have like a pretty big solver network, but like really it's just like a bunch of people like running bots, and I know them as like addresses, not like people for the most part, right? And so like it's one of these things where for us, what we are focusing on right now is MEV internalization, and letting searchers in a very easy way on board to start helping apps internalize MEV. And this is typically not intense. It's typically something even more complex for searchers. But what we've done with our smart contract framework is to take a lot of the risk out of it, like not just for users, but also for searchers and solvers, or whatever you want to call them. Because like there's actually a ton, dude, there's like a ton of ways that solvers can get wrecked. And so like when you look at FastLane, like more than half the team were like searchers or solvers at some point. Like it's very much like a protocol where we wanted to standardize a lot of the safety features. And so apps can just put, our little SDK in their front end, and then searchers can just very easily onboard because we've done 95% of the heavy lifting when it comes to security. And when it comes to like making sure that like the user's not, rugging them, or there's no free look problem, or, like floating bids or anything like that. And so from our standpoint, we like this approach because we don't have to worry about the lack of solvers leading to a lack of users wanting to get their intents filled. For us, these are apps that are already going and they already are generating MEV, and they don't have to change anything just to internalize it other than like update their front end. And so this is kind of like that first step. And then the second step is like, and I think this might be what you're really asking, is like, how do we then take that where we've got application specific sequencing for these apps with these solvers involved in a way that's like very abstract and pretty easy to like scale horizontally for the solvers? And how do we then start swapping that over to an intent system in much the same way that Uniswap added Uniswap X and that 1inch added 1inch Fusion? And that's where, like with Atlas, we do also have the ability to very easily do intents. The question just becomes, do the apps want intents? And it's interesting, like some of them do, and others are like, well, why would we ever fuck over our liquidity providers like that? And so it actually becomes like very political. And from our point of view, like we're very neutral. Like I think there's also like some really, really cool networks. So like one of the things that Khalani can do that we can't is like we actually can't use two different like apps to solve each other. Like we talked about this before, like sharing MEV just becomes very political. But like with Khalani, like it's very easy to do something like that. It's like really, really cool. And so I do think that intents have like a really interesting way to compose together. It's not clear to me yet that different apps want their intents to compose with each other. But I think that eventually we're going to get to a point where they kind of have to, because otherwise there's just going to be too much money left on the table, because there is value in composability. There is value in coincidences of wants. I think we might be pretty far away from that, but I think we will get there eventually.
Did that sum it up for you, Jasper? Do you want to give your thoughts on it before we wrap up?
Please.
I wanted to hear theirs.
Yeah, I don't know. I'm going to ask this really quick. I know we're going over time, so if you have to go, let me know. But I want to, if we get a lot of like, consumers in crypto listening to this kind of stuff, who want to learn more, what's the landscape looking like? Is there a world coming soon where users can participate in solving through like providing like their LP to like solvers directly, not like kind of like not what Nomial's doing. We talked to them a couple of weeks ago, but more like this inventory problem working directly with solvers in the way that you would do like an LP pool to provide.
Oh yeah, very cool. Very soon.
Yeah, who's doing that, or what's that look like now? Because I know there's like a lot of interest.
Khalani.
People, like
We're doing it.
Oh, epic! All right, now I know where to go.
Well, let's take a step back, because I don't think, like Kevin, I don't think you guys are just like letting like LPs put money in, and then solvers are just like, all right, we're gonna turn on our algorithm and like make even more money for you. Anyone who's good at making money with capital is not going to want to use other people's money. Like if you're good at market making, you don't want to have investors give you money, because pretty much all of the good solving strategies, this is for MEV as well as market making as well as intent fulfillment, are capital constrained. Where like if you just like double the amount of money you have, you're basically just cutting your ROI in half, because you're still making the same nominal amount of profit, but now you have twice as many investors to give those funds back to. And so like it's one of those things where like my take on this, Matt, is that like, yeah, it's possible. I don't think that's very likely, because I think that the people that are good at it don't need anyone else's money to do it, if that makes sense. I think though that there is one important caveat and like a huge carve out that I would say is the exception to the rule. And I think this is probably what Kevin is getting at, which is finality solving. Solvers that are handling cross-chain bridging inventory. These are typically the least sophisticated. I'm kind of dunking on them a little bit, but these are like typically like the solvers with like the least amount of sophistication. It's also this like type of solving that has like the lowest ROI of all of them, because you do have a ton of capital that's typically locked up in bridges for a long period of time. You also don't have to be like it's not like a hard thing to just be like, all right, I'm going to transfer money from Arbitrum to Ethereum. Like it's not like a hard integration. If you want to get like, really deep in the weeds and like, have like a very strong predictive model for like, is Ethereum likely to reorg or something like that, then like you could try, but like good luck with doing that unless you work at like, Coinbase or Binance or something like that. And so in my mind, like a lot of these finality solvers right now are in like a race where the more risk they take on, the higher their yield. And so far, all of the L2s in Ethereum are centralized sequencers. Like no solver who's like handling finality between chains is going to get rugged by like the OP like sequencer. Like they're not going to get rugged by the base sequencer. They're not going to get rugged by the arbitrary sequencer. And so like right now, it's a very easy type of solving. The return on the assets is very low compared to like market making or even like atomic arb or like liquidations. But once these L2s decentralize their sequencers, and like once they do so also in a way where like they're different and you have to actually learn the quirks of each of these decentralized sequencer networks, because maybe there is like a way for a sequencer to rug a like finality solver, which there are in a decentralized sequencer network, absolutely. Like that's where things are going to get a lot more interesting. And I think that we're going to see like more solvers come in. I think we're going to see a lot of them get wrecked, because right now this game of chicken that they're playing is fundamentally not sustainable. But yeah, like I do see that kind of solving having a high demand for capital. And I think that like if users are looking to deploy assets to an agent or someone to manage it for them, bridging and just like having it get locked up in a bridge is probably the one thing that still has capacity for passive investors to like actually do something.
Interesting. The reason that came up in conversation was like people talking about this kind of citadel running solvers, right? Like this small group of people that have the capacity to run solvers. But if we bring this kind of this user being able to direct their funds into this agent or whatever, that it's kind of like an argument. It doesn't fix the problem. It's still the same thing, just with lots of people piggybacking on one centralized, if you like. But what's your take on, are we going to get to a truly decentralized kind of solver landscape, or is it always going to be this case that the Citadel reigns supreme?
From my point of view, I'm less interested in a decentralized solver landscape. I think that like with solvers in particular, like if being centralized is faster, solvers will be centralized. As long as the dependencies on those solvers are decentralized, that's fine with me. Like as long as like if there's a solver just running like one bot in a centralized way, but if he fails and there's like someone else to, do the exact same thing for you, there's like a backup or a backup, and that part is decentralized, and that's fine. In my mind,
you're saying the solving or the fulfillment, you don't care about centralization as long as it's like permissionless. Anybody can do it as long as it's like profitable, right?
And that the permissionlessness to me is what's most important. Because like what we're seeing right now is all of these solver networks, like 1inch Fusion, like Uniswap X, even CowSwap are permissioned. They're whitelisted. If you want to be a solver on CowSwap, you have to bond like 2 million or something like Cow. If you want to do Uniswap X, you have to like go through, I think, KYC. You have to get on their whitelist. And these are like very permissioned systems. And I think that from my point of view, So we built Atlas to be permissionless for solvers, and we really had to go out of our way to do it. It's actually extremely difficult to have permissionless solving. But like for us, that is the main focus, because like, let's say we do get to that world where most solvers are just like not making money, so they turn off their machine. What we don't want to have happen is for there to just be, I don't know, 2 teams building blocks in all of Ethereum. And then all of a sudden, like both of them get shut down by the government, and then we have 0 teams building blocks. Like we need this ability for like new people to have, like even if entrenched people are winning, we need new people to be able to compete with very low friction. And the key of that, like the core of that, is permissionlessness.
Permissionless solving removes the censorship monopoly of the solvers, right? I think that's sort of like the thing. Like as long as you offer profit, doesn't matter who you are in reality, like somebody can solve it for you, and that's the beauty of that side of things.
Correct.
Kevin, how do you feel about that?
Yeah,
He's going to reference Tarun's paper.
No, actually, I'm going to reference the opposite of Tarun's paper. I think there will be permissionless solving, but probably for a different reason, right? The way I look at it is, I mean, we talk about there are so many applications just say, hey, we're gonna just run auctions and we'll have solvers coming in and solve for us. But if you take a very solver-centric view, it's actually very difficult for solver to participate in multiple auctions or multiple, settlements, because the risk is, I can bid in multiple concurrent auctions, but what if I win all of them, or I win none of them, right? So there's if there's not a there's not a permissionless settlement platform, aka counterparty selection platform, then I don't know how many. I can't concurrently bid in many auctions because I have no idea what's my risk exposure is. I might win all of them, or I may win, only none of them, right? But if there is a solver-centric sort of settlement platform, or we call it clearance platform, where multiple auctions clear on the same, try to settle or clear on the same platform. Obviously, I'm talking about Khalani. Then from a solver's point of view, I can actually go and bid in multiple concurrent auctions, because the settlement or this clearance platform will guarantee that I can have capped risk exposure, right? I only want to bid 1,000 USDC, but I want to bid in 10 different auctions. I'm going to bid my maximum inventory, knowing that, I won't win 10 of them. If I win 10 of them, then I'm bonded, I'll be slashed or whatever. That's kind of bad. But the settlement platform will make sure that I won't double spend my 1,000 USDC in 10 different auctions, right? So once you have something like that, permissionless and solver-centric sort of settlement platform, then solvers are going to a lot more aggressive to bid in these auctions. So for these auctions or order flow places, it's a lot easier for them to have solvers in the first place, right? So I think that's kind of the reason I feel that this permissionless solving or permissionless auction platform or permissionless sort of counterparty selection platform will emerge. It's not that a auction cannot sustain too many solvers. It's the other way around, right? It's a solver cannot have exposure to too many concurrent auctions.
Isn't that just a coincidence of once?
Coincidence once between who and who?
Like because I'm assuming all of the auctions have to have the same like periodicity, like they have to end at the same time, otherwise you can't batch them all together. And so if you've got different auctions for like buys and sells and you're merging them all together so that they end at the same time, wouldn't that just be like a batch auction?
You could, right? But
I do understand what you're saying though, with like
how do you
merging
coordinate? right? How do you coordinate, right?
Well,
So
I think
you
like,
want to,
sorry, go ahead.
yeah, I mean, you want to have, so basically you want to have this permissionless platform where you can merge, like you said, right? Supply and demand, right? So you have demand for, solving or bits, and you have supply for bits. If they don't come together in like a meta auction or like a giant aggregator of marketplaces, it's very difficult for both sides to I guess to settle together, right? Once you are allowing them to be in the same place, um, then you have a market structure can sort of give both sides guarantees. Yeah.
I think like so the way a lot of market makers handle this kind of thing is with this concept of like an inventory skew, where like if you've got like your book and you've got your inventory, and if in any like discrete moment in time you've got a little bit too much of this asset and a little bit too little of this asset, you'll have like your global view of your whole thing, and you'll kind of skew your prices in one way or the other to kind of offset your inventory leanings. And like I am very intrigued with the potential for a system like what you're describing, Kevin, to take different market makers' SKUs and reconcile them in like a private and
That's
trustless
exactly
way.
it. Yeah.
I think that's really cool. I also think that it's going to be very hard to do without either like a TEE or FHE or ZK. And so it is fascinating to me though, and I am very bullish on that concept in general. But you can dude, if another market maker figures out what your SKU is, like it's going to completely ruin your ability to be competitive because they will have a lot of information about your bidding strategies. And so yeah, you have to have an element of privacy there. Plus like all these things are like discrete trades too, and so it's kind of like you never really like there's a latency element that you'd be adding by doing that. But it is like a really fascinating thing to think about, and I think that like eventually I hope we can get there.
The next CK will be solved by CK.
Hell yeah.
Guys, I think we could go on for hours. I feel like one day I want someone to write like the Flash Boys book, but for Web3 journey, because I feel like all this kind of discussion is so intertwined with like all these strategies going on in the blockchain. My mind, like I said before the episode started, my mind's going to melt on this episode, and it definitely has. And I know the community would love to keep picking your brain. I just got a few DMs actually in that last hour. People said that this was an incredible conversation for them and have learned a lot, which is really, really great to hear. This is why we do these calls. So thank you, Alex and Kevin, for jumping on. I'm probably going to listen to it 5 times just to make sure that I've really understood like a good Kevin tweet. But guys, thank you so much. If you don't know what I'm referring to, go and jump onto Kevin's Twitter. And
I defined skew at the end there. I defined inventory skew at the end. So Kevin,
you balanced it right at the end.
We had the same number of definitions.
Perfect.
Awesome. Alex, Kevin, thanks
thanks
guys
for having
so much.
me. It's great talk.
And thanks
for
Jasper as
having me,
well. Nice one. We'll be back next week with episode 4. All right, guys. Catch
All
you
right.
later.
See you guys.
Bye.